I'm working on smalltalk, working on some animation. YouTube says this is still upcoming. Okay. Let's say I'm live. I guess there's a delay. 2, 3, testing. Okay, I just got to learn to trust this now. Whatever I did to make YouTube eat my videos is no longer happening. All right, so talking about this, what right here is a Glamorous Toolkit. It's a smalltalk environment built on top of Pharaoh, which is a modern smalltalk. And recently, I've been doing some experiments with getting drawing some things that are eventually going to be part of animations that I'm doing for binary expressions, expressions in propositional logic. So that, what you just saw, those are the true and false nodes of a tree. And then here is some, this is a little graph that this is a little graph that represents a syntax tree for such an expression. So variables are these x0, x1, x2, and then they're XORed and AND together, ANDed together, and so on. So these are just little components of a graph. Today I wanted to work on an animation. I'm not actually going to animate a graph. I'm going to just start from scratch with a completely new drawing, which I call truth table animation. So let's let's add a Pharaoh snippet so we can write code in here. And I'm going to start with just drawing a box. So BL elements. So the graphics engine is called Bloc, and Smalltalk does not have. It only has one top level namespace, so you tend to use naming conventions to disambiguate. So a BL element is an element of a drawing, and they're compositional, so they have a geometry. Actually, I think we can say extent, size maybe. And so if we say just something like 32 by 32, I think it's square by default, or rectangular by default. And then if I say background, I'll say color from hex string, and then 333333. Right, but you have to put this in parens because otherwise the background and from hex string form a message. And let's just draw that. So I'm going to hit Control G, and I'm going to get a new tab off to the right over here. And if I click on it live, then I can actually see it. Okay, so that's what I want. And I think I can give it a stroke. Nope. How do I give things a stroke? So if I go back to this one, well, he's definitely had. Okay, well, I have block example. So this will tell me how to do it. So this is something I made a long time ago. This one I made a long time ago. And if I look at the code for this, so view the code. So BL border paint color black, that's what I want. Oh yes, border is what it's called. So not stroke. I was calling it stroke. I should call it. In fact, let me just open this in a new tab up here so I can get back to that if I don't need anymore. So this will be my reference. Okay, so and then border is a new border object which again takes as far as parentheses. All right, so if I inspect this or hit Control G, oh, you can't see that because it's It's actually really dark. But if I do the white version, or actually I think I usually use E. It's okay. So I'm going to call this an array slot. How about a I'm going to call this an array cell. Truth table cell, an array cell. I mean, it's kind of a general purpose array thing, right? You know, I'll be drawing arrays in boxes, so it's something would have a value in it. In fact, if I put, I was going to say I could call it a BL text element, and I could say text is 1. Oops. A string or block value. Should be a block. Oh, a text must be an instance of text. Oh, I see. So I have to say 1 as roped. Get that. I'm going to say align. How do you do that? So we have to actually look at we want to browse this class, and we want to actually probably look at, I did the stencil, not one. So that would be under Bex. So const is the one that has a label on it. Oh, I see. I see what it is. So it's a BL vertical pane with the geometry. And then a line center. Okay, so BL vertical pane. Just copy that. And then everything else is the same. Do I want this to be a Bex? This is not. Is this a binary expression? Not really. So that almost tells me that maybe Bex is like some graph element, because I'm developing some kind of like visual language here, right? Then this was garbage. So all this stuff that I had written about the text element can now apply to the BR vertical pane. BR is brick. So brick is a level up from bloc, the widget library. Then we say add child, and then BL text element new with the text 1 as row. Oh, does not understand new align center because I left out the spacing between those two words. And And there we go. That's what I want. Okay. I say that's good enough for now. And for the other case, I do want to switch these. Not the border, but I want to switch this. I want to make this white on a dark background. It's very much like what I did for the expression, so it makes me think that like this should be a cell, but whatever. Okay, and then also the I did the same color thing here. So node text. Get the text to do that, I had to say t add attribute, color white. I feel like this is overly verbose, and there's probably a way to do it, but I don't know how to do it in less words than this. I know how to say take a string as rope text, put a font name on it. The reason is that like, I don't think you can say like I want to say like if I do this like oops, so the world, I run this, you can't see it because it's white, so blue, make it blue and should say hello world in blue. I change the font, impact, should say so what I want ideally would be to say text, or just like hello as roped text, font name, console is whatever you want. And then some other thing like attribute text color red. But that does not work. Because instance of text color did not understand is paragraph attribute. So I need to like investigate what that is. Oh, I'm looking at the wrong thing. I want to browse this. So I think I hit Control that, and then I can get a new tab on it. Okay, so and if I move this over, I can see the face. Or yeah, I can see the the what do you call this? The browser. Yeah. Okay. So we got like background, embellishment. Text replacing attribute. This does not seem like Like this seems to be things that are on the widget, right? The widget level. What I want is text attributes that are on. Well, maybe that's not what I want. Maybe the mistake is that I'm expecting attribute to do something. So if I say nil here, I'm expecting. I was expecting one of these little drop downs, but I'm not seeing it. So bl run rote text. If I browse this one, instead, there's got to be some DT text attributes. Oh, this would be a view of this thing. Not what I want. Self attributes from to self size. Maybe maybe it just takes a list. Instead of saying attribute, you say attributes, and then we would say text color blue. But let's do text color red. Oh, that seems to have. Nope, does not work. Instance of text color did not understand is paragraph attribute. What if I just add that method and say false? Good block. Why are we selecting the attributes? So a text color. Red. We're just gonna try this. Okay, and then we zoom in on this, and then this is not a debugger. It doesn't have the debug buttons. This is just an error message that got trapped, and then it was showing me what it did. But now if I run this, so it also doesn't understand is adornment. Okay, so clearly that was not the way to do it. So what if I added up here? Yeah, I think I bet you could say as text. as text. So that works. Right, that I expected to be there. Or just kind of guessed it would be there. See, I don't know what text and string and all these things are. This isn't helping. Scrolling through this nonsense doesn't help. But we can look through here. We can filter this way. We've got text. So a text is a character string with abstract changes, okay, in appearance. And then how does that relate to a rope text? Well, I would think a rope text is a particular data structure. Roped text. I am a concrete implementation of a text model. BL text for more information. Okay, let's actually go ahead and look at this. So let's open this. But we should see what text as rope text does. If I go to text, this is really slow. Rope text is self as string as rope text. So basically, this is just turning it back to a string and then applying the. So text and rope text are completely different things. We have to say apply to BL text from start to size. That seems verbose. Seems like the. Let me just go. So my guess is this is something they made for Glamorous, and it just hasn't. I mean, maybe they're happy with this API, but I bet it just hasn't had the time to get polished down by people refactoring things. So I bet you can say so. The T is hello as roped text. Font name. Oh, let's put. Just so this says BL run rope text string. Okay, so yeah. So Okay, so we have to actually go to this thing and say, you don't do it from the Solus, and then A is going to be text color blue. Let's get rid of all this. And then A, not add attribute, but copying from the other window. A, apply to BL text and then the argument is just T. Then we want to return T. That does the work. Yeah, I think this font or this run rope text should have a method. It has font name. Where does it get font name from? It must be inheriting that. BL text. Oh, that's black as in the typographic concept, making it dark. Foreground. Could that be it? Right, so if we just say T foreground, we'll make it a different color, gold. Color gold. Color green. Okay, so T foreground is what I want. So T foreground color blue. All right, so the whole thing would then just be hello as rope text, font name Consolus, foreground color blue. Boom. Okay. All right, so now we know how to do that. And then BL text element new text is this. Right. And we can copy this and put right, but we don't actually want the word hello work. We just want this, and then we're going to make it. Right, so dark is going to be this color, or rather, that'll be light. So background light. Light is this color, and dark is 23. The border is going to be black, And then this one is going to be light. Oops. Dark. No. What? Oh, okay. So it's a 1, so it's light. So the foreground should be dark. Right. And then when it's and then we'll say we'll just say so say v is equal to 0, and then we'll say if v equals 0, v equals 1, if true, then we'll say foreground. So we have to declare these things. So local variables foreground and background. Nope, can't do that. Maybe that's because we haven't used them yet. So because it's only mad about background. Foreground is going to be equal to dark. I want the situation I have right here. So foreground is equal to dark. Background is equal to light. And string is going to be equal to 1. And so then we're going to say string as rote text here. And make this foreground. Make this a background as the BG. Oh, does not understand something. Instance, a full block closure did not understand if true. What? Oh. Right, because that's not you don't want a block there. You just want the value. You want a Boolean. Right. This one now says do not understand. SBL background was set to no. We said background is BG. BG is light. Oh, because I don't have a false situation. All right. So we say if true, and then if false, foreground equals light. BG equals dark, string is equal to 0. We remove this dot, and then it's all one message. Okay. I feel like that's too dark. Is it always that dark? Maybe I use this color? Yeah, I think that's kind of what I was expecting. Maybe something in the middle. Like, 50, 50, 50. 48, 48, 48. 40, 40, 40. No, that's not 40. It's 40. All right, whatever. That's close enough. It's still a little too dark. How about something like that? That's about right. Okay. So I'm imagining making this into a class now. So this would be like as element, right? So now let's I don't want that. I guess what do I call the class? Put it in. Just cell? Excel maybe? It's not really, it really has nothing to do with Bex. Um, so I want a new package in this repo, and I'm going to call it what? Oh, I don't think you make it here. I think well, maybe you can, but yeah, you can't. You don't make a new repo here. You make it from the coder. You have to make an object in this. So let's make a coder, and we're going to create a new class, and the class is called. Surely there's something in the system called cell already, right? Like that. That seems like there's not. Cell morph, ft cell morph. So my library, when it was in Godot, was called Fnarbmelix, which was just a random assortment of letters that didn't make sense to say in English. But in ages and ages ago, I had one called Game Sketchlib, and that was made in processing. And so let's call it a GSL cell, Game Sketchlib cell. Or just GSL. All right, so we'll make that. We'll make that class. GS cell. It's an object, and it's in Game Sketch Lib. I don't know what tags are. We don't know what these are yet. I guess actually I do know what the slots are. The slots would be foreground and background and string. Text. And the comment is, I represent a cell in an array. I visually represent a cell. Okay. And now we're going to add, now that we have that, we can go back here and we can say GSL new. And then we'll say as element. As element. And then when I put the dot there, then it knows that that's a complete sentence, and it can't find this. Message is not implemented, so let's implement it. And so we create a method as element in class GSL. And then we put this in here. In fact, we just put the whole thing in here. Oh. And just paste it. And it's interesting. It seems like it didn't. Oh, so well, these dark and light. Okay, so dark, light, and V are just local variables. V would and I called it text, didn't I? Let's just put this back in here. So this all works, and then let's just get it to run. And so now if I run this statement, boom, we get that. Okay. And so now yeah, I'm starting to think about like, oh, maybe putting this in a palette or something, but no, that's not what I want to do right now. It's just make V an element of the class and get rid of it from here. Now it's going to be, and we can just click here and say add slot V in GSL, and we run it. And now when we run this statement up here, it's going to complain. It did not complain. Why didn't it complain? I just say, oh, because it's nil. Okay, that makes sense. So if so string should be as string as row text. I think this is going to say nil. Yeah, nil. Okay. And we don't want that. So what we should do instead is the other thing, instead of just saying as element, do this. We can just say new, and then in the class here, we'll add a GT what would you call it? Element? GT element 4? GT drawing 4? I think that's what I called it in. And then this is a GT view. And then for a view. And then return a view explicit. I think the text is drawing. Oh, we should call it sketch because it's a sketch lib, right? So if it's sketch 4, then the text is sketch. And then I think the word is drawing. Nope, painting. Okay, so we'll just save that. And let's look at what I did for Bex again. So in Bex, GT drawing for stencil, self-stencil is it. Stencil self as element. So now if I render this error, okay, not understand text. Title is the word. Now I see a sketch. It's no. Okay. Okay. But in addition to that, this element should be string yes string. So we actually don't need this. I think instead what I want to do is I just want to put a string in there. I think I'm just going to make the value be an empty string. Right? Like the default value will be an empty string. And we don't need a string here. So you do that, you make like the constructor kind of thing. So you say initialize. And you say super initialize. And then you say you fill in the values. So by default, a cell will be white, foreground will be color black, and then V would be the empty string. So by default, it's just a white box. So now if I run this, here's my sketch, and it's just an empty box, and that's what I want to see. Okay. When I inspect this class, I have foreground, background, and I think if I right-click on this, I can create accessors. And in background, I can create accessors. In text, I can create accessors. And that, if I want to create an accessor, I probably want to rename it. What happens if I rename it? I'm looking for like a refactoring tool. Like I can just rename it, but rename instance variable. So that says Control R, so why can't I do it here? If I go here and I press Control R, it lets me rename it, and I'll say thou. Nope. Let's highlight it, Control R, thou. Nope. Hmm. All right, well, that renaming didn't seem to work, but that's okay. Let's say add that slot. Now it's up here, and we'll get rid of this one, and we'll save that. And then, well, I imagine that has broken something. In fact, I know it has broken something. I referenced V somewhere. Maybe I don't. Maybe that was the only place I referenced it. I do here. Surprised that didn't give me an error. All right, well, use value instead of V. Here we go. And do I need a, oh, wait, submit that. And I guess I don't need a text in here. So text goes away. And we can delete this. Delete that. And then now we can just add accessors for this. Okay. So now, so we can say foreground color red, background, what would we say, color white, background color red, and value, or yeah, value is stop. Yeah, red sign says stop. Okay. Right, because it's hard coding the colors in there. This is starting to look very much like use value instead of B. That's part of the problem. Value. I'm surprised I'm not getting runtime errors for this. I would certainly expect to get a runtime error. I don't know why I'm not. Because it clearly knew it wasn't defined here. But then at runtime. So here we have a sketch. It does say stop, but it's not the right color because of what I said a minute ago. Because the background is BG and not this. So this can go away. All this can go away. Not go away completely, but we're gonna take it out of this class. And then down here we'll put I think, okay, yeah, you just can't put that in the middle of it. Okay, so now, ooh, oh, yeah, okay, that, all this is being evaluated. I don't want it to be evaluated. Now I have a sketch and it says stop. That's what I expect. Maybe for now, instead of size, we just say fit content. Min extent. Minimum extent. How about that? Would be 32 by 32. So don't make anything smaller than that. All right, and then now let's see what happens. Error. Minimum extent did not understand that. Okay. Let's just leave that out for now and just say fit content for now. Don't need that right away. Oh, maybe I do need that right away. That's too small. You know what? I'm just going to go back to just hard coding the size for now. That's not clearly not the. But it's clearly not the right way to do it. But it's good enough for now. And I'll fix it later because that's a very visible, bug or whatever. An undefined object. Okay. Okay. All right. So now I want a BR horizontal. Is it a flow? That doesn't seem right. Didn't I just use a vertical flow? Vertical something? BR vertical pane, but now there's no horizontal pane? Oh, there is. All right, so BR horizontal pane, new, add children, and a list. And then we're going to call, let's do this. Let's make a let's do, I'm going to make this a function. So let's say this is going to eventually be a constructor. So bit is going to be sort of, like new bit, whatever, new bit. So let's say GSL new bit. Right now it's just new. Maybe it's just bit. Right? And it takes a value v, and then so If true, do this. If false, do this. So actually we want C. Right, so then C is equal to GS cell new value V. V equals 1 if true. C foreground dark. C background light. If false, C foreground light. C background dark. Okay, and then these will just be eventually these really should be moved into a C dark and light. They'll be moved into like some kind of palette object. C and then okay, and then we're going to return C. Oh yeah, I need to return C. Yeah, we do. All right, so now we're going to add children. G or we'll say bit value 0, bit value 1, bit value 0, bit value. We'll do 1 and 0. This is going to be an XOR. This is the truth table for the XOR operation. I think it should go 0, 1, 1, 0. That's what I'm expecting to see. Name already defined. In here. Does not understand. Instance the cell did not understand V. New value V. Oh, right, because I didn't. I don't expect this to be one GS cell. I expect it to be like the many. The table, right, is like this. Table. Why is it that? Okay, let me think. Add children. Am I using the wrong kind of? I don't think so. I think this is wrong. It gave me a does not understand parent. So that's a symbol. That's not correct. It was right before. Creating a dynamic array. Oh, this is Not how that works. Does not understand. Instance of GSL did not understand parent. Yeah, so okay, so you don't use a return. You just use the last expression, and then you want to say E as element. That's about right. Fit content. Don't really like the way that border is being drawn, but other than that, that's what I want to see. Oh. Okay. Yeah, whenever I move off camera, the little face thing, face detector thing is supposed to bring me back into line. Okay, so and I bet I could say I think I can say this. I can say even this way. 0, 1, 1, 0 collect bit. I think this works. Let's just add like an extra one. Instance of small integer did not understand bit. Collect. Oh, I see, because that would have been passing the message to that. Instead, I want, yeah, this. There we go. That's what I want. I don't want to pass the symbol. I want to pass the actual block. That's no longer a truth table. Now, can I say 16 bits? No. All right, so let me just browse a number like 5. An integer, meta. Bit string length. Okay. Bit string base n. Bit string, so I say print string string base 2. That's and I say how do I do it? I don't want to evaluate it. I just want to print it. Control P. I don't want. Okay, that gives me what I want, but I want those as numbers, not as. I mean, yeah, that's how you do it. I just thought maybe there was like some way to get the numbers. Points to number of digits in base. This does logarithm. Oh. Actually, you know what? So what's kind of interesting is that I want these to be I want the bits to be backwards from whatever they want, whatever they're going to say, because I want what I'm trying to draw is the pattern that looks like this. Right. So this is what the goal is to draw this. We've got 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 1, 1, 0, 0, 1, 1. 0, 1, 0, 1, 0, 1, 0, 1. So these are the 3-bit numbers from 0, 1, 2, 3, 4, 5, 6, and 7. And so this is the most significant bit. Right, so you read them from top to bottom. But then I want to draw I want to draw these as truth tables. So when I draw this, I actually want this to be the low bit. So this is not what's this number? This would be 1 plus 2 plus 4 plus 8, which would be 15. Right? It would be the same as right. So this is not 15, but rather 15 times 2, 4, 8, 16. So 15 times 16. So whatever that is, 100 and 15 times 16. 240. So what I want is maybe integer has one. You know what? I guess what I really want is like I really want like the number 5. I want this. So this is division. I don't need division. I need I can use division back. So I need something like this. I want it to do this, like so like 2 bits, is equal to, so n is going to be the number, and then we're going to say, so let's call it m, result. So result is height array new. I guess we'll have so length k. So we'll give it how many bits to use. So n, so k to 1 by -1 to, so n, and we'll call that so what we want to say is, oh yeah, I'm going backwards. This actually works out nice. So we'll say r at k at I put, and then we're going to say so m is going to be like our I like to call it n0 and just n. So n is equal to n0. Oops. N gets n0. R gets byte array new of length k. K to 1. K to 1 by -1 do a. All right, so R at position I put n, the current value, bit and 1. So that gives us the last bit. And then n is equal to n bit shift 1. So shift over 1 bit. And that's it. That's it. All right, so if we evaluate this, we say Control G to do it. Full block closure, okay, and if I say 2 bits on value 5, value 8, as so let's say 15, right? So I want this number. In fact, let's just say, oh, yeah, that's fine. And we'll say Control G. And that gave me a small integer. So at the end of this, I want to return R. Byte array. That gave me 1 bit here. Bit shift 1. I probably want to bit shift -1. There we go. That's the number I wanted. That's exactly what I wanted. So now we'll say uh, 5. Oh no, 2 bits. 2 bits value 5, value 8. Gives me the bits. Select bit, and so we need to put this in another layer of parentheses. And improper store into indexable object. Okay. I didn't read the stack. What's happening here? So self putting a byte array at what? At index is 1. Value is vertical pane. All right, wait, so this is, I run this part, I get this over here, I think, right? Yes. And I run, oh, so this part doesn't work. Select bit. Why can't I do that? That works. Can I return a string? Does it have to be the same byte array? Can I make it map to something else? Oh, you cannot map a byte array to something. Okay, so that all right. So rather than a byte array, how about R as ordered collection? All right, so now it's an ordered collection instead of a byte array, and maybe that works. Yeah, that works. Okay. And that's what I wanted. Okay. So I'm thinking of calling this like a register bitvec or something like GS bitvec. Bit vector. Yeah, I really feel like this should be a function on the number class, but you can do that in Smalltalk. You can add extensions to it. I don't like it though. I don't like the practice of polluting other people's libraries. Why don't I like it? Well, okay, in JavaScript, that is something that people would do. And they would make you know, like there was an old library called Prototype, and it would, you know, extend like basic JavaScript features. Like it would add methods onto the array object and to the string object and stuff. And that seemed kind of like a bad thing to do, because if other people did it, then you would get collisions. And this happens in Smalltalk all the time. Like because there's no namespaces, it's easy for things to collide when you start adding libraries. And yet you see this all the time. Like, they're always adding things, but maybe you add with your own namespace. I don't know. I don't know. All right. Well, let's add. Let's go ahead and add it to number. Why not? Let's inspect this. Let's inspect this number. Let's inspect this number. Go to meta. Maybe we go up here to hierarchy and just go to integer. Just add a method called 2 bits. And then the number of bits, so k bits. Convert to an array into an ordered collection. Of n bits. Convert me to an ordered collection of n. Then we copy this. Then we change n0 to self. RS order collection. And then we want to call this like my thing. We want to call it GS game sketch list. I think that's how you mark it as being part of your class or your package. Let's see. Oh, so I have to actually add this thing. I have to add, now I say game sketch list. I didn't add it before because you can't add things for me. But you have to add it to the repo here, up to date, and now it's all this new stuff, including I see, yes, so integer to bits. That's nice. Okay, so that was what I needed to do. Now we're adding that to the class of integer. Cool. Okay. 11:27. So I really wanted to get this animated right now, and I spent so far just gotten it to draw. And so this is now part of the number, right? So now we can go back to this thing, and we can just say so 15 2 bits 8. And if we observe this, we get the ordered collection. Okay. So now we would say 5 2 bits 8. Nobody else in the world would ever want that, right? Nobody would want it this way. Like anybody else in their right mind, and usually me, would want it the other way around. Like if I wanted to generate this as a column, I would want it the other way around. But here we want them reversed. So in here, we should return it. It's kind of neat how you can do that. Cool. So we'll reverse it and then reverse it at the call site as well. So now if we just say 5 2 bits 8, right, that's exactly what we would expect. Is it? No. It was already reversed. It was already in the right order. Okay, so this as ordered collections, because like we're working backwards here. Let's just return to a byte array in bits. Let's just return this, and then as ordered collection. It doesn't understand the highlighted part. Oh, okay. As ordered collection. Is that what I want? But what I want is for this to, when I type in 2, it's R in this language, 2R 00 11011 or whatever like that, whatever that is. 1 2 3 4 1 2 3 4. And I would want that to be in this exact order. That's what I want to see. And it's not because I reversed it. Okay. This is actually fine. Yeah, I'm confusing myself because this is what I want. The actual problem does not have anything to do with this display. It's that this is the low bit of the truth table. No, this is the low bit of the number, whatever this number is. $53. This number is the low bit is 1, but in this truth table, this is the high bit, right? Because we're counting from left to right. But it's not that I want the confusion I have is that it's not that I want the low bit to be like it's that I want the bits in this order. Like the whole point of doing it doesn't like if I want to draw this truth table, what number do I put in? Well, I want a convenient notation for drawing for like I want this to be the notation for writing the truth table. So to do that, that's what I need to do. That's why I need to reverse the bits. But there's no actual reversing in the code. It's reversing in my head. That's the problem, right? Because like in Rust, when I'm working in Bex and I'm talking about this bit vector, I want to refer to this slot as bit 0. Yeah, like in an array, you want this to be arrays. You want this to be the slot 0, slot 1. Like you want this enumeration. You want numbers to flow from right, indices to flow from right to left. But in like this is the 2 to the 0 place, the 1's place. This is the 2 to the 2's place. The 2 This is 2 to the 0. This is 2 to the 1. This is 2 to the 2. Right? So the places are backward. But I'm just completely confusing myself. This is completely normal. Basically, we have a we have a big endian writing system, right? So we start with the big end and then we write to the low end. And this is a little endian display. But I just want this bit pattern, right? So that's all that it is. Like it doesn't matter that this is the low number. That completely does not matter. Although it did cause me a tremendous amount of confusion the other way when I was working on this in Rust because I'm mapping from bits to well, I guess in Rust, because I'm into like I'm talking about bit number something, right? I had to refer to the bit number, and so to access that bit, I actually had to like shift shift right and then and with 1. Okay, so okay. But here I'm not actually. Excuse me. I'm not accessing like bits as an array. I'm confusing myself, and it's getting close to midnight, and I think I'm just going to stop here. All right, so part one, draw a truth table. I haven't gotten to animation yet, but I've had a really long day followed other really long days. All right, this is far enough, right? All right, we'll continue this tomorrow if I have a chance. Let me go ahead and check this in. And I'm just going to check it all in as so start on animating, start on drawing truth tables for animation. I kind of consider all this like prototype code. I'm trying to make it as nice as possible so that I can eventually reuse it, but like I don't know what it's going to be in the future. So I'm not really like sharing this, and will and am publishing it to GitHub Tangent Storm Fair. Oh, I just remote desynchronized. All right, so I have to. I'm checked into version control, so let's pull and rebase. No, I don't want to do that because it made a merge commit, I'm sure. So he or TDD ver TS Barrel. Yeah, merge. And say get rebase. But now this is going to be mad. Whatever. Now I can push it. All right, well, didn't quite get to animation, but I got a truth table drawn. So the idea is that now I want to draw this as well. So let's draw this first, real quick. So let's call this row is equal to n, or is not equal to n. Sorry, so we're going to say n to bits 8. Fit content. Boom. And then table is going to be a br vertical pane new, add children, and then fit content. And then we're just gonna bring these numbers in here. And paste that number so 2R. I'm gonna say row value. Yeah. Let's add a. What would you add? Just a BL element. New size 10 by 10. Just a spacer. Yeah, that's what I'm going for. The idea, this is a this is the truth table, and so here we're seeing the bits of the index of the truth table. And so you can think of this as input variable 0, this is input variable 1, and this is input variable 2, which I call x0, x1, and x2 in Vexland. And the question is, what happens? And so this is some function of those three variables. And the question is, what happens when you swap? You rewrite your function and you swap the inputs. And the answer is, well, if you swap these two bits, then 0 stays the same. 1 becomes 2, 2 becomes 1. This stays the same. This stays the same. And then these two swap. So these two get swapped and these two get swapped. And that's the permutation. Now what happens if you swap this one and this one? Well, this moves over here. So this is going to move to where this one is. Because this moved up here. These two swapped. And if these two swap, well, then you're going to have 1, 1, 0. So it goes to this spot. Basically, the idea is that all you have to do is rearrange these rows, and those give you new numbers in binary that tell you where to move the values. And so I want to animate that. So that's what I'm going to work on tomorrow or whenever. All right, but I'm going to bed. So this is it. Thanks for watching. This is, not a presentation. This is just a watch me code kind of thing. I guess I'll make a little thing to show where I wound up at and make this the thumbnail, and then I'm going to head out. I think that did it. Yeah, so save the snapshot. All right, so thanks for watching, and I'll see you again soon.